today we will discuss about refraction at a convex spherical surface. All of you are familiar with the refraction. What is meant by refraction? You are familiar. So before discussing what is meant by this, let us see the diagram first. Okay, see the diagram. So here we can see an object O is kept in a medium having refractive index N1. And here a convex surface is the spherical surface which is having refractive index N2. Okay. So to get the image, two rays are needed. So here one ray is go undeviated and another ray ON is incident on this surface. So here what happens? Here we can draw the normal. So here NC is the normal at this point N. So we can mark this angle as angle of incidence and this angle as angle of refraction. Okay. Clear? So these two rays are meeting at the position I. So we can say I is the position where image is. Okay. For I is the point. For I is the at that point image is 4. Okay. So here this we can mark it as object distance, and this we can mark it as Mi, we can mark it as image distance, and MC is the radius of curvature. Okay. So OM is the object distance, Mi is the image distance, V, and CM is the radius of curvature. Okay. Is it clear? Up to this it is clear, no? And now we are considering some cases, we are considering some assumptions are there. So which are the assumptions? The object is a point object. The aperture of the surface, aperture is very small. Aperture is small. Aperture of the spherical surface is small. And third one, the angles are smaller. The angle I and R, all angles are small, so that tan of that angle, tan I can be approximately equal to I, and tan R, or any angles, all its sine or tan angles of that can be approximated as that angle itself. Okay. All the angles, okay, not only this, all this, if we are considering this angle tan or NOM, NCM, all those angles can be approximated to, tan of that angles can be approximated to that angle only. Okay, so here we can write angles, the angles are small. We can write better instead of writing like this, the angles are small, so that sine of that angle, sine of the angle or tan of the angle can be approximately equal to the angle itself. Okay, is it clear? Because the angles, aperture is very small, angle, this angles also made will be very small. Okay, and now we are going to find an expression connecting object distance, image distance, and radius of curvature. In term, and refractive indices also will be there. N1 is the refractive index of the first medium in which object is kept. N2 is the refractive index of the second medium where image is. Okay. Now we can start. So to obtain that relation, first we can consider the various angles. Okay. So we are finding first tan. We can find first tan NOM. Tan angle NOM. What it will be? tan angle NOM can be written as NM by OM. No? NM by OM. Why we are doing so? Because we are assuming aperture is very small. So that's why this curve distance and straight line distance will be equal. Okay. Similarly, tan NCM can be written as tan NCM is equal to NM by CM, and tan NIM can be written as NM by IM. Okay. Now, all for small angles tan theta can be approximately equal to theta. So tan NOM, instead of that we can write angle NOM is equal to NM by OM, angle NCM is equal to NM by CM, and angle NIM is equal to NM by IM. Now we know Snell's law. What is Snell's law? Sin I by sin R is equal to N2. So for small angles, sin theta can be equal to theta. So we can write I by R is equal to N2 by N1, or we can write N1I is equal to N2R. N1I is equal to N2R. Now we have to find I and R. So to find I and R, we are considering the triangle NOC. Okay. Consider the triangle NOC. So from the triangle NOC, I is the exterior angle. So I can be written as angle NOM plus angle NCM. No? I is equal to angle NOM plus angle NCM. Exterior angle is equal to sum of interior opposite angles. So NOM plus NCM. To find angle R, we can write angle NCM is equal to I plus angle NIM. No? From the triangle, but it is NIC. No? If we are considering the triangle NIC, by considering the triangle NIC, we can write angle NCM is equal to angle R plus angle NIM, or angle R is equal to angle NCM minus angle NIM. Okay, we can substitute here, or we can simplify once again. NCM, angle NCM, but we can write NM by CM, and here NM by IM. So R, we got it like this. Same way we can write I also. How we will get I? I is equal to angle NOM plus angle NCM. NOM can be written as NM by OM. For small angles, tan theta you have to write. For small angles, tan theta is approximately equal to theta. So NM by OM plus NM by CM. So we got I and R. So that we can substitute here. Okay. So N1 into, what is I? NM by OM plus NM by CM is equal to N2 into NM by CM minus NM by IM. So NM can be cancelled. No. What you will get? N1 by OM and N1 by CM is there, that we can take to that side, and N2 by IM we can take to here. So plus N2 by IM is equal to N2 by CM minus N1 by CM. Okay. NM we are cancelling. CM term we are taking to one side. So here N2 by CM is there, here N1 by CM is there. If you take to that side, it will become minus N1 by CM. n1 by OM. Here minus n2 by IM we are taking to this side. Now we are applying Sine Convention. So when we apply Sine Convention, what we will get? OM. This object distance, incident light direction is positive. What we discussed, same there only. That only. Okay. All distances should be measured from the pole. Distances measured in the direction of incident light is taken as positive, opposite is negative. Okay. So here OM will be, OM can be written as minus U. Okay. So we can write OM is equal to minus U. Then MI is equal to plus V. CM is equal to plus R. All those are in incident light direction only. Okay. So if you substitute here, what you will get? N1 by minus U plus N2 by V is equal to N2 minus N1 by R. So we can write minus N1 by U plus N2 by V is equal to N2 minus N1 by R. So this is the expression for the refraction of light at a convex spherical surface. Okay, minus N1 by U plus N2 by V is equal to N2 minus N1 by R, where U is object distance, V is image distance, R is the radius of curvature, N1 and N2. N1 is the refractive index of first medium in which object is kept, N2 is the refractive index of the medium where image is formed. And when you are solving problems, what you have to do? Whichever quantities are given, for them you have to apply Sine Convention, and unknown quantities sign you will get automatically. Okay, is it clear? Okay. So now we will discuss about length maker's formula. So we are considering a convex, both surfaces, both convex surfaces we are considering. Okay. So one convex lens we are considering, and let R1 and R2 are the radii of curvature of the surfaces. So N1 is the refractive index of the medium in which that lens is kept. N2 is the refractive index of the lens. So for the refraction at surface ABC, we can write for refraction at the surface ABC. For the refraction at the surface ABC, we can write the equation. We know that minus N1 by U. What is the formula? Minus N1 by U plus N2 by V is equal to N2 minus N1 by R. That is the formula. So here we have to apply that formula. Here what happens? So when the light is incident at the surface ABC, it will form an image, virtual image at I1. Okay, I1 will be the image formed. And this I1 image is acting as the object for the second surface ABC, so that final image is formed at I. Okay, object is here, and when the light is incident on the surface ABC, it forms that both rays will form an image at I1, and that image is acting as the virtual object, so that final image is formed at I. So if we apply here, what we will get? Minus N1 by U plus N2 by V1. Here object distance is equal to N2 minus N1 by R. So this formula we have to apply. Okay. So we will get for refraction at the surface ABC. Same for refraction at ADC, what we will get? For the refraction at the surface ADC, we can write here, this will act as the object, so we can write minus N2 by V1 plus N1 by V is equal to N1 minus N2 by R. Okay, is it clear? Why? Because that why it is so? Because this is acting as the object and final image is formed at I. That's why we can write it as. So if we are adding 1 and 2, okay, 1 plus 2, what you will get? 1 plus 2. N2 by V1 will get cancelled. You will get minus N1 by U plus N1 by V is equal to N2 minus N1 into 1 by R1 minus 1 by R2. Can we write? Here N1 minus N2 is there. If we are taking minus sign, it will become N2 minus N1. Okay. N1 can be taken to that side. So what you will get? 1 by V minus 1 by U is equal to N2 minus N1 by N1 into 1 by R1 minus 1 by R2. Okay, this is our third equation. Now, if object is at infinity, if U is infinity, we can write image will be formed at the focus. So what we will get? 1 by F is equal to N2 minus N1 by N1 into 1 by R1 minus 1 by R2. Okay, and this formula is known as Lensmaker's formula. Why it is known as Lensmaker's formula? Because we can design lens of suitable focal length if we know the radii of curvature of the lens, and N1 means in which that lens should be kept. Normally we are considering it as air. If it is air, N1 is 1. Okay, so we can design lenses of suitable focal lengths. That's why it is known as Lensmaker's formula. Okay, this is Lensmaker's formula. So this is, we can write it as the fourth equation. So from the 3 and 4, what we can write? RHS part is same, so we can write 1 by F is equal to 1 by V minus 1 by U, and this is our thin lens formula. Why it is known as thin lens formula? Because when we are deriving these expressions are valid by, as we said, there are certain assumptions. Which are the assumptions? The lens is very thin, object is point object, angles made are very, very small. Okay, then only we can obtain this relation, because when we are considering for refraction at the surface ABC and ADC, we are considering the distance actually from the optical center only. Okay, that is possible if and only if the lens is very thin. Okay, so this is Lensmaker's formula and this is thin lens formula. So when you are solving problems based on this, that later on we will discuss. Okay, how to solve problems based on this. I hope all of you understood it. No? If you are having any doubt, contact me. Thank you.